Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. In this video, I would like to show you how I will do part modeling for this flat coil spring. If you look at this photo, we have a flat coil spring here. This flat coil spring is mounted on top of the base plate, and this base plate is mounted on this lid. If you look in this photo, at one end of the coil spring is kind of hinged to the slot, and the other end of the coil spring will be hinged to the pin of the. If you look in this photo, we have a pulley here. In the previous video, I've already shown you how I do the part modeling of this pulley. If you look at the one side of this pulley, we have a pin here. So it means that this pulley will be mounted on top of this, and one end of this flat coil spring will be hinged here, and this coil spring will be wrapped into spiral, and another one end of the coil spring will be fixed at this slot. So the idea to have this flat coil spring is that when we pull the handle, so the handle will rotate the pulley and will rotate also the blades, but the coil spring have the energy to push back this handle and also this rope to its initial position. So that's why they have a coil spring. Alright, so in Solidworks, sometimes when you do Solidworks, you can start doing your Solidworks not in part modeling, but also you can do a new part modeling in assembly. Let me show you the idea of me to do the part modeling of the flat coil spring. I will start in assembly mode. Why I started in assembly mode is that the idea when I go to assembly mode, I will insert the lid, the base plate, and also the pulley. So I assemble all these three components into correct position. So then from there I know where is my initial point, my initial position for me to do my part modeling of the flat coil spring. Let me show you. So I will not do in part modeling. So what I will do in assembly, then I click OK. So if you look here, this is the interface of this assembly. Let me cancel first. So we have the interface of assembly. It's kind of different from part modeling. So if you look in the interface, make sure the unit is mmgs first. Okay, when you insert, okay, assembly, we have a tab here, assembly. So under sub menu of this assembly tab, we have insert component. Then I click at insert component. So I select, first I will select the lid. So I just click OK. So the lids appear on the screen, but I do not click anywhere on the screen. I just simply click green button OK. So it means the lid will be the first component to be inserted in this file. So it will be kind of a base component. So if you look, the lid, they have a bracket F. Bracket F means the lid is fixed, so I cannot move the lid. So it is in fixed mode. Okay, then I will go insert component again. Now I will select the base plate and also the pulley. So first, what I will do, I will put the base plate, then I will put the pulley here. Alright, now I need to put my base plate into correct position. So that's why I need to do mate setting. If you look here under assembly, we have another option called mate. I click at mate. So what I will do, I will select this cylindrical surface of this base plate and this rod, so it mesh in concentric. Then I click OK. But now the other setting is that, okay, if you look at this base plate, we have a key here, and it must mesh to that slot vertical face. So what I will do, I will select this space of this base plate, must mesh with the slot face here, so it will, I click OK. So what it shows here, this it is in line in position because that face and that face is coincide. So my next mate setting for this base plate, I need to select the top surface to be laying on the spring, but it's kind of hard for me to select the face. So I simply click OK, then I go to section mode. And while I am in section mode, so easy for me to select the internal face. Okay, my other mate setting will be this plane of this base plate will mesh with this surface here, so it will coincide to that surface. So now my base plate in position. Okay, let me off the section view. The next will be the pulley, so I click and mate again. Okay, the pulley, I select the cylindrical surface of this pulley must match with this rod, and but pulley will go to the other direction. Under the setting on the left here, under mate alignment, I will go for this one is default is anti-align. I go for align, so the pulley will go to the other direction. So I click OK first. So now I can select. Okay, I click OK first. I go to section view, then click OK. So I will do this space of this pulley. Hold on, I must click at mate setting first. Mate setting, this space must coincide with this surface of the base plate. So now if I click OK, my pulley and my base plate are in position. Okay, now the base plate and the pulley are in position. If I look in this section view, so I know this is a space where I can do, okay, at this plane, this is where I can start doing my modeling of my flat coil spring. But I need to check first what is the available space. So I got to go to evaluate and measure this edge to this edge, and it shows that the distance is 3. So it means that when I do modeling of my flat coil spring, the thickness of this coil spring will not be greater than 3 millimeter. Alright, okay, as I mentioned to you, I do this part modeling of my coil spring in assembly mode. Okay, if you look here, under assembly here, normally when we insert a component, it means we insert all the parts that we have already done, like for example this base plate and this pulley. But in my case, I not insert component. If you look here under insert component, the second option is a new part. It means that I insert a new part to do modeling. So if you look in the list here, we have part 8 here, so it means I am inserting a new part modeling into this sub-assembly. I know that my flat spring will be laying on this at this plane, so I just simply click at the surface. So it means I have a sketch mode. If you look, we have kind of a sketch the interface here, like what we did in part modeling. So under this sketch mode, I'm now in part 8. It means a new part modeling. So I can, what I need to do, I simply select this circular edge. I need to convert that to entities, and also let me off this sketch. Is it the sketch? Let me off the section view and let me hide this lid for a while. And also, if you look, I have a trace image that curve. I have just converted to entity. So under this part 8 again, under this sketch mode, I click edit again. I need to trace this spin also, because this trace curve is as my guide curve for me to do modeling of this coil spring. So these circular edges also need to convert to entities. So I have this, okay, to trace curve. Let me exit the sketch again, and let me hide this. Let me hide this, not this base plate, this pulley. I hide it, and let me unhide. Show again the lid itself. Okay, the lid. Okay, the lid also. Okay, make sure that I'm in part 8. This is very important. Make sure I'm in part 8 rolling. Under this sketch, I edit it again. So now at this lid, I need to trace another edge to become as my guide curve. So the edge that I need is this slot edge, all the edge that I need to be traced. So I will select this edge, this edge, these the edges that I need, and also these edges, carefully select these edges. So I just simply click convert to entities. So now I have the, if I see the sketch, so I have a trace curve, the trace curve. Okay, now if I exit my new part modeling, okay, under this part, so I have this guideline. So the idea of it is that, okay, now I can go to separate mode, not in assembly. Okay, if I click at this part 8 here, so we have a cursor appear here, a dialog box. I open part in position. It means I open this part 8, a new part modeling in assembly, into its separate mode, into new part modeling mode. So it will open line the like the kind that we do new part modeling. So we are now in part modeling. No more, we are no longer in assembly. So but it have dynamic link. Whatever I update in this, my part modeling will be updated into this assembly. So now I'm in separate mode. So now I can let me save first this file as just click OK. Then I will name it as Flat Coil Spring. Alright, so I will start do this modeling of this coil spring. So I have this curve as my guide. Let me edit this sketch. So all this sketch I need to convert it into construction geometry. So I will exit the sketch, and okay, then I will add, please take note on this, I will add another plane on the front plane. Since the sketch is on the front plane, I create another new sketch plane. Okay, that new sketch plane is for me to do my starting point to do the spiral curve. Okay, to do the spiral curve, similar if you remember in my previous video where I do the curve driven pattern for the arms of the shaft, I use helix. Helix we have curve and we have a spiral shape, but the helix we have height and revolution. But for flat coil spring, it's not helix, it's kind of spiral, flat spiral. So it means we have revolution and a pitch number, and we don't have the height, but it still need the base circle. We must create a base circle to do the spiral. So in this plane, I will create a base circle to start my spiral curve. So we need a base circle. So in this sketch mode, do not exit your sketch. I'm still in the sketch mode. Under features here, we have curve, we have helix and spiral. If you look here, I already done the setting. The option previously I use height in revolution for the helix curve, but we are not using height and revolution, we are using spiral. I mean, we are doing flat spiral. Okay, if you look the pitch number is the distance between the curve and the curve of the spiral. If I put it to, we have more close spiral distance, much bigger, and I think I should put it into 1. And also, if you look in terms of revolution, if, like for example, I go for 5 revolution, it means the revolution of our spiral up until 5 revolution. If I go for around 12, I think 12 is good enough. So I want my spiral to not pass through this curve, this slot curve here. So I think 12 is good enough. I'm doing for my mode of spiral is I'm not using clockwise, I go for counterclockwise. And okay, the start angle is also important. If you look here, my start angle is at this point. I want my start angle somewhere at this spin curve. So if I go for 0 degree, if you look, kind of like mesh. It means the start of my spiral is at this point, but I must check again the other end. Alright, I think this is good enough for me. Then I click OK. So I have this spiral just created for me to do this coil spring. Okay, you must take note on this again. Okay, I'm not using this original spiral curve. What I will do is I need to convert this to entities. It means at the same front plane, I make another sketch. So this is a new sketch plane. So I will duplicate this spiral. I select this spiral curve. Since this spiral curve is on the not on sketch 6 on the other sketch plane, so I simply select this spiral. I convert that to entities. It means I have a duplicated version of this spiral. So this, I'm now in sketch 6. So this sketch 6 means that I can edit it. It means I can trim it. Before that, I add a line here to make kind like at the end of the spiral we have a hook shape, something like this, Okay, sometimes it happens like this. Let me add another line again from this point, like this. So that this is kind like we don't have to make this fully defined, but as long and simply we kind of like adjusting mesh. Or maybe I can set this and this to parallel, and also this and this to parallel, and this parallel. So, and also this edge and this edge parallel. Okay, I don't have to make it fully defined, so this is just a coil spring, and this portion I can trim it. So I have one end of my coil spring is have the kind of a hook shape, and the other end, if you look, this will be the pin. If you look at this curve here, will be the location of our pin, and the spiral, the other end of the spiral curve will kind of like have a hook. So to this pin, so I will select this. I convert that to entities, so I have this thing. It means I have to stop my spiral up until this point. I need to trim it, so I kind of have a boundary. So what I will do, I will trim this portion, and I also trim this part, and also I will trim this part, and also I will trim this part. So we kind of like a hook shape there for our spiral curve. Okay, let me save first my file, and okay, I'm now in the sketch 6. So what I will do, and I will before that, let me put some fillet angle here. Let's go for fillet 1. Let me try. We have let's go for 0.5 at all this corner, and also at this point, and let me try this point if I can do that. Yeah, I can. Yes, we have a fillet. Okay, then what I will do, since this spiral is not, I don't have a thickness, it's kind of a thin curve, I can do under surface. Under surface we have extruded surface. So this is how much the thickness of this coil spring. So the distance is 3, as I mentioned. The height of the coil spring is 3, and I simply click OK. Then this will be our coil spring. So but this coil spring, if you look, they don't have any thickness. This is still surface. We don't have solid body, so it's mentioned here surface body. So I need kind of like to give extra thickness to make it solid. So in surface mode we have thicken here. So let me go for 0.1, since the coil spring is very thin, and I select this thing, and I must make sure that the flow of this is, if I zoom in, the flow is not inward for this thicken. I should go for the first option, say go outward direction. So I have the okay. If I click OK, then I have a solid kind with thickness of this coil spring. Let me save my file, and if you look back in the assembly, everything is automatically will be updated in our assembly file. If you look there, our coil spring is nicely positioned, and it kind of like if I on my pulley, it will wrap into the pulley. Let me go for section view. If I go for the top view, just to check, to show you, we have a coil spring wrapped into the pulley, and also the other end of the coil spring, it hinged to the this slot. Okay, I believe this how we do. I hope you understand how we do the modeling of this flat coil spring. So let me save my file. Okay, Alhamdulillah, I have completed my flat coil spring for my mini blender. I hope you understand my video, so if you can try to implement the procedure of me doing this modeling of this coil spring to your mini blender project. Okay, inshallah, in the next video I show you some other few parts or part modeling and also the assembly of this mini blender. Before that, do not forget to click like and subscribe my channel. I'll see you soon in the next video. Assalamu alaikum warahmatullahi wabarakatuh.